In this video, we'll explore fraction division from the measurement division perspective. Now, often when we talk about dividing fractions, we tell students to invert and multiply or keep change flip. What this means is we're going to multiply the first fraction by the reciprocal of the second fraction. So let's look at our example. 9/13 divided by 6/7. We change this to multiplication and flip the second fraction. And we got 9/13 times 7/6. We multiply across, that gives us 63, and then 13 times 6 is 78. Then we want to simplify our fraction, and we get 21/26. This will work for whole numbers as well. All we have to do first is change them to improper fractions over 1. So 9 over 1 divided by 6 over 1. Now we multiply by the reciprocal, and we get 9 over 1 times 1/6. And we know 9 times 1 is 9, 1 times 6 is 6, and then we simplify our fraction and get 3/2. Now, how do we understand this? Because it is kind of confusing to think about having fractional groups of another fraction. So let's look at 9/4 divided by 3/8. Talk about how many groups of 3/8 are in 9/4, which is kind of a weird wording. But let's put it in a context to help make sense. Say I'm going to have a bake sale, and I know that to make a pie, it takes 3/8 a cup of sugar, and I have 2 1/4 cups or 9/4 cups of sugar. I don't know how many pies does that allow me to bake. Okay, so what I'm looking for here is how many groups of 3/8 cups of sugar can I get from 9/4 cups of sugar, and that leads me to 9/4 divided by 3/8. Now, how can we look at this in a more generalized term? If you remember, every division equation has an equivalent multiplication equation. Now let's look at what happens if we plug in fractional versions for a and b. So I know that when I have two fractions being divided equals some value, I know that that value times the second fraction will equal the first. Now what we have to ask ourselves is, what can we multiply c over d by to create a over b? And what we have to do is we have to be able to cancel the c and the d and be left with ab, so we can multiply it by this whole expression. Now let's plug it in and see what happens. So I'm going to plug this in for the question mark, and what I can notice is because all three of these are multiplication, I can just multiply across and simplify, or I can also see that things cancel. My two d's would cancel, my two c's cancel. That leaves me with ab equals ab. And what this tells me then is that when I have a over b divided by c over d, that question mark that it's going to equal is the multiplying by the reciprocal. And that's why we know multiplying by the reciprocal works.